Hello and welcome to math today. We're doing solving compound inequalities and we're going to do the second day. So the learning target last time we met was solving and graphing compound inequalities with the OR. And if you recall, when we did the OR, things were graphed and they went out. Okay, that was an OR solution. Called a union is another vocab word that we used. Today, what we are going to be doing is solving and graphing compound inequalities with and. So last time we met, I said it was like, okay, your mom gives you a choice and you can clean your room or the bathroom, then you can go ahead and do whatever it is you want to do. So you choose to do cleaning either your bedroom or the bathroom. Now today, she's not giving you an option. She's using the word and that means you need to clean the bathroom and clean your room, then you can go ahead and do whatever it is that you want to do. All right, so compound inequalities, that's what we talked about when there's going to be two of them. We did union on day one, that was the OR problems, and today we're going to be doing the intersection, which is going to be an AND problem. All right, and OR, compound, when two simple inequalities are combined into one statement using AND or OR. All right, so when we graph these, and if you look at this, it says 2. Let's just read this part right here. And read it from the X, any number greater than 2. So we have an open circle here at 2, and we shade anything greater than. Now, if we erase this, and now we look at that statement, and we are going to look at it from the other end and do the variable and the letter, that says any number less than 6. So we have the open circle here and less than, and you see where those two lines, they're facing each other. So where they're overlapping, where every number fits the same, is where we are here between them. Okay? And the only difference from this example and the next example is that you can see that this symbol right here has a line underneath it, so we have closed circles. Okay, otherwise everything is the same. Now if we look at what we did last time we met, and you look at these graphs, see how those graphs are going out? So it goes out and out. They go away from each other. Okay, they go outside, away from each other. Those are the ORs. All right, intersection is what we are talking about today. And in this intersection, the sets that are common to both, we still might have parentheses, and it has the and in it. All right, first sample. Remember how last time we met, we did the example number 1 on the first line, and then the second line, and then the third line was putting them both on there. So let's look at this first one, and we're going to put our 0, and we have the number 2. It's an open circle because there's no line underneath it, and that says any number greater than 2, and greater than, our numbers get bigger to the right. Now the second one in purple here says any number less than 10. So we go up to 10. It's an open circle because there's no line underneath it, and it says any number less than 10. Well, less than 10 goes this way. And what happens is, see, I can't even do them separate because I always do them on the same line. So really, this is what the red one's going to look like. So when we take the green one and the purple one and we combine them and put them on the same line, you see that the green line goes one way and the purple line goes the other. But every solution has to fit both. So what we end up doing is shading between. Because if I pick this number down here, -5, does -5 work for the first one? Is -5 bigger than 2? No, it's not. It works for the second one, where any number less than 10, but it doesn't work for the first one. And because this is an AND problem, the number has to work for both situations. So that's why we write it this way. Now, most often, because we know math people like to write things very concisely, short, they don't like to waste a lot of extra times. We say they're being lazy sometimes. A more efficient way of writing this is, do you see how we have the letter X in between? And these two numbers, if you look at this graph here, this graph is bounded by the two numbers 2 and 10. So the smallest number is 2 and the biggest number is 10. And we always put these less than symbols in here. Sometimes it's less than or equal to, but in this case, it's just less than. So most often you're going to see people write it this way. Okay, a number less than the letter is less than 10. So when it's an and, because it has to fit both, the letters in the middle, and you put the numbers on the outside. All right, second problem. See how they wrote this all like this? They didn't do it any separately. Everything is all together here. Well, it's kind of like we're putting a line here and a line here. And now because we have two lines on the symbol, you need to put a number on each side of the line. So we need to put a number here, a number here, and a number here on every side of the line. Well, our job is still the same. We want to get X by itself. What number is by the X that we need to move away? It is a +1, and the inverse operation to adding 1 is going to be subtract 1, subtract 1, subtract 1. Now use your calculator so that you get -5 minus 1 is a -6. No multiplying, so we're just going to leave our symbol the same. And now this 1 minus 1 cancels out, and we have an X. And 2 minus 1 is 1. Okay, so now when we graph this, see how this is an and we have that X in the middle here. So we have 0 on the number line, and we have a -6, and we have a 1. They are both open circles. Now you can do this a couple different ways. Some of you are going to recognize when you have that X in the middle and the symbols are going both ways, you just shade right here between this. This is an and. It has to fit bigger than 6 and less than 1. Some of you are going to want to look at it and graph just this. Now remember, we have to read from the letter. So it says any number greater than -6. So greater than -6 would be this way. And now you have to also read it. So if I erase this mark in here, and now I have to go ahead and read this from the other side, we need the letter. It says any number less than 1. So from 1, less than is this way. So you can see how we're bounded by -6 and 1, and we shade in between. So the ands, we're going to shade between the two numbers. All right, so this one looks kind of the same as the last one. So we're going to draw these lines down. And what number is by the X? We've got a -10. What's the opposite of subtracting 10? So we're going to add 10, add 10, add 10. So we have to put it in all three places. So -9 plus 10 is 1. Then we have the symbol less than, and we have your X because -10 plus 10 is going to cancel out. And now we have -5 plus 10. Use your calculators. So 10 minus 5 is 5. Okay, see how these symbols are both pointing to the left. So we have 0 on your number line, we have a 1 on the number line, and a 5 on the number line. Neither one of these symbols has the equal sign underneath. So we're going to have open circles at both. And this one says X is bigger than 1, so bigger than 1. The other side says X is less than 5. So it goes this way. Whenever those two arrows are passing each other like that, we know we are going to shade between. You cannot just leave it as the two arrows passing. If you leave your answer like this, and it goes this way, and it goes this way, and you leave it like that, this means all real numbers. Okay, we do not have all real numbers as a solution here. We have the numbers between 1 and 5, so you have to make sure that you go down and shade between 1 and 5. If you don't shade, then you are telling me all real numbers, and that is not the solution here. All right, can you read this graph? Do you see how we are going between two numbers? Between the two numbers, we've got a -9 and a -2. Both of those circles are open. So I just go like this, okay, no lines underneath. And now I just fill in my numbers. -9 is the smallest one. It's already on the number line. And -2 is the biggest. Okay, when you have and problems, that's all you have to do. When you're shading between, like we are here, you put the X between. So you just put the symbols in, less than. Okay, now I go, okay, open circle, so no lines underneath. The smallest number here is a -2, and the biggest number here is a 5. That is how your compound and inequalities get written. All right, we are at the end of the lesson for today. So this was compound inequalities, and on your graph, you could have an open circle and a closed circle, but the big thing is that you are going to shade between. It's like having less than X, and this other side would be less than or equal to, and then you just put in whatever numbers are there. So if we have a -2 here is the smallest and an 8 here, then that's what we fill in, -2 and 8, and we put the X in between. So these were your and compound inequalities.